Welcome to the technology panel, the AirMiners panel. Very quickly, we'll do introductions, and then we're actually going to dive into each of the panelists doing a very quick introduction of themselves and their company, and then we'll go into a discussion. I'm your moderator for today. My name's Heidi Lim. I'm the Chief of Staff at Opus 12, and we're a carbon tech company that has created a I personally, as a plug for AirMiners, have been in this community for a couple of years and have been pretty active. I benefited quite a lot, and I'd say like my transition from working in outside of carbon tech into the field has been largely because of the community. So I highly recommend, if you are somebody who's starting to get into the space, definitely stick around, come to the events, and continue to be active on Slack. Great. So today for the tech panel, we have Christian Shearer, the CEO and founder of Regen Network. We also have Daniel Egger, who's the head of marketing and sales at Climeworks, and Peter Eisenberger, the co-founder and managing director of Global Thermostat. So we have folks across the board from natural solutions to direct air capture. We're going to have a great discussion today. Start with a very brief overview of each company, and then we'll go into the discussion. We have a bunch of questions, and then we also have an eye on the Q&A that you guys have been submitting your own questions. So with that, Christian, do you want to give us a quick overview, and then we'll go to Daniel and then Peter?
Absolutely. Thanks, Heidi. Can you hear me well?
Yep, we can hear you.
Great. Well, thanks so much for having me. I'm happy here presenting biological drawdown technology solutions. My name is Christian Shearer. I'm the CEO of a company called Regen Network. I want to just zoom out for a second here. You know, carbon is simply one of many indicators that indicates to us that something is seriously wrong with the way that we're managing this planet. The carbon cycle has clearly been disrupted. The carbon cycle is one that is inherently biological. Trees, grasses, animals, soil, carbon dioxide, dinosaurs, and even all the hydrocarbons that we're burning that came from decomposition a few years ago. So the most effective solution from my perspective to address the underlying problem, not just address the symptom, which doesn't only help us solve the immediate challenge that we're facing, but also helps us solve the underlying problems that got us here in the first place. So it needs to include, to a very high level, biological solutions to those problems. So the way that I see it and the way that Regen Network sees it is that these biological systems, including carbon, are considered a public good. And the problem right now is that markets fail to account for these public goods, and they're generally considered externalities. Business as usual profits from degrading these public goods. And in order to reverse this trend, the provision of public goods has to be valued. So Regen Network is building a technology that allows us to value it. There's two really important things that have to happen for us to be able to value public goods. First, we need to verify for all the various stakeholders who benefit that this public good is of value and has actually been produced. Second, we need to quantify the value being generated possible without robust and open science and a public ledger to keep track of all this. If we can't efficiently achieve consensus about the value of public goods, we can't effectively value it, and therefore we can't continue to degrade it as a matter of course. Regen Network is building a full stack and open source software development kit, including a domain-specific blockchain to power the many, many different applications that are needed in this space, starting with the verification and issuance of biological carbon credits. So I'm looking forward to talking with you more, discussing with this panel as we get into it. Thanks for having me.
Awesome. Thanks, Christian. All right, we'll go to Daniel next.
Hello, everyone. Good to talk to you, and thanks for the opportunity for being here. I believe we have the biggest challenge in front of us humanity ever faced, and this is climate change. And to tackle this issue, I think we need to have strong visions. we need to have a vision of being carbon neutral by mid of this century. And we need to have a vision to be carbon negative in the second half of this century. Before we're having this panel, we discussed that we would like to talk about technologies, but we do not want to talk about technologies we will have maybe in 5 or 10 years. We want to talk about technologies we already have today. And for that, I have 3 items with me. I have a piece of stone. I have a small bottle with fuel. And at last, a cucumber. What these 3 things have to do with this topic? I would like to explain you that. So what we would like to do today is we would like to connect the vision with reality. And how do we see the reality? Reality is that if we would like to become carbon neutral by mid of this century, in a first step, we need to reduce our emissions. So we need to decarbonize as much as we can. But we also know that this is not possible for all solutions, for all technologies, for all industries. So already today we have a market for carbon dioxide, and this is the cucumber. Carbon dioxide is a fertilizer for vegetables in greenhouses. And we at Climeworks, we do have a project exactly doing that. So we are capturing carbon dioxide from the air with machines, and the CO2 is fed into a greenhouse and used there as a fertilizer. But not only that, we will also have future requirements for carbon dioxide, for future usages with technologies we already have today. And this brings me to this small bottle of fuel. What you see in here is these are hydrocarbons. This is a liquid you can use as a fuel, and this is basically made out of CO2 and water. This seems to be futuristic. Actually, it is not. So imagine if you burn a fuel, what you get out of it is CO2 and water. It's a chemical process, and this any chemical process, you can also reverse that. So basically, you can see it take CO2 and water and synthesize this to fuels and use this as an energy source. But we are also aware that this is not enough. There's already too much carbon out there, so we need to take it back. We need to take it back from the atmosphere, and we need to bring it somewhere. And this brings me to this little stone here. This stone comes from Iceland, and in Iceland there is a project called Carbfix, and Carbfix is pumping CO2 underground, and the CO2 there reacts with the stone, and basically it mineralizes. So within about 2 years' time, the carbon dioxide is turned into mineral. And this project is also connected with the machine from Climeworks, where we're capturing the CO2 from air, pump it underground, and there it's stored safely and permanently. We at Climeworks, we are simply building these machines with the technology we call direct air capture. So far we have around 15 machines in operation all over Europe. We're still a rather small team based in Zurich with around 100 Climeworkers taking this challenge. And I'm also looking forward to a fruitful and powerful discussions we have here today. Thanks for having me.
Thank you, Daniel. Great. And then lastly, let's go for Peter.
Hi, I'm Peter Eisenberger. I'm the co-founder and CTO of Global Thermostat. Our company was formed with a very distinctive vision. That is, we not only attempted to solve the carbon problem, but have it embedded in what is also the global problem of poverty and equity. And as was mentioned, carbon is the form of the cycle of life.
No worries.
It's also the cycle of our life as well. And the Global Thermostat has a plan that says we can use the carbon in a way that's natural, but in an industrial version, to capture all the benefits that organic carbon brings. But carbon is certainly not a waste material. It is the molecule of life. And therefore, there are various ways, some of which have been discussed here, that can be used to monetize the carbon and turn it into valuable products. Matter of fact, in the short, our company is based on the vision that we're going to turn the climate problem from a threat into an opportunity. And there's a need for emergency and mobilization and fast implementation of this. And it's much easier to think about doing that if instead of the way it's pictured till now as coming as a cost to the society that's going to interfere with the development and uplifting of the millions and billions of people that live in poverty. Rather, if it's viewed as a way to stimulate a new global economy that we call the renewable energy and materials economy, we have a much greater chance of all pulling together and solving this problem. And the basic notion is that the process that Klaus has talked about and has been mentioned here, if you take CO2 from the air and use a renewable energy to split water and get hydrogen, you have the inputs to what is the organic life cycle that produces both the energy for life and the structure of trees and materials. And we are imagining the same, mimicking that process, which we're doing, combining technologies that have been discussed and producing both our energy and materials. And in particular, people make estimates, as was done earlier, and says there's not enough materials in order to sequester in a way that you generate value in our buildings and our bridges and our infrastructure. But what they fail to do, what they fail to take into account, is that if we're going to address poverty and achieve equity, there has to be an enormous growth in this century, an economic growth of about a factor of 10 to 20. And in that factor of 10 to 20, magically, all the sources where we could sequester carbon that look inadequate today become adequate, more than adequate, actually. So if the rest of the world was to make the sort of transformation that China is making and build a whole new infrastructure, there's plenty of concrete and steel and materials in which to sequester it. So we really believe that it's very important that we all come together and decide whether what I'm saying makes sense or it's not real, because if it can be achieved, then you can change the paradigm that currently exists from thinking about climate change as a threat, but rather turning it into an opportunity. One final thing I'll say is that the issue, as Klaus mentioned, has to do with cost. And it's true that all technologies can benefit from learning by reducing their cost, but it makes a difference how you approach the problem. And we believe that we have a technology that can currently today can produce CO2 for under $200 a ton, and within a very short period of time can get under $50 a ton. And we're involved in a very productive collaboration, believe it or not, with ExxonMobil, the company that, of course, has contributed to the current problem while it provided the needs that enable modern life to develop. And in doing that and working with them, we're trying to scale up our technology to the gigaton scale necessary to address the threat of climate change. So I want to echo what has been said here. We have the tools, we have the capabilities, we have all the creative minds, some of which are here, and many, many others who are working in laboratories across the world to try to find ways to do it. And finally, I add, everybody's talking about it, was mentioned in the introduction to this conference. There is an analogy between the pandemic and what we're going through here. The pandemic bends the curve we have to bend the curve of the curve. And in doing that, we will be able to achieve address the threat of climate change. And the point I'm trying to make here and get across is we can do it at the same time we address the needs of the billions of people that are living in poverty today. Thank you very much.
Yeah.
Great. All right, thank you all. Yeah, so I want to go back to this, something that Daniel mentioned just to kick us off, because I think there's a lot of people across the room who are starting to think about carbon removal or about carbon tech. How do you think about the difference between just reducing emissions and drawdown, and what is kind of the synergy between the two and how your technologies fit into there?
So I would say, I mean, in the first time, we simply need to start to reduce. There is no way around. And also all the technologies, they're basically able to clean up, and they're able to provide the carbon for technologies and industries which cannot be carbonized, but there's no way around for decarbonization in the first step. There our position is completely clear. But what we see is that the decarbonization cannot be in such an extent as it should be to get carbon neutral, to become net zero. And this is why we are needing these technologies. So, and these technologies are needed in two ways. In one way, that we can provide the carbon we will need in the future. We are relying on carbon. Our economy is built up on carbon, and this carbon needs to come from somewhere. And there we simply need to close the carbon cycle, and the source will be the air. And in the second step, we also need to remove carbon because there's simply too much out there. And there we need to have different technologies, taking them out of the air and storing them permanently and safely. And these are the two things we need to do. It is not an either or, it is an and. So we need to have a portfolio of solutions where we have all these different aspects integrated.
Christian?
Pieces here. This one is one you'll hit on, which is that you know, carbon is necessary, but not for what. Second piece, you know, we're already above 400 parts per million, so we need to create.
Okay, I think, Christian, you're having some audio issues. I don't know if you can hear me, but you might want to dial in with your phone.
I'll speak while Christian addresses his audio problem.
Okay.
So I think Klaus made the point in the introduction that, you know, there's been so much accumulated CO2 in the atmosphere that trying to withdraw it simply with organic methods like trees is not going to be adequate. I agree that we should do the best we can. And we obviously want healthy forests no matter what. And all the stuff that's organic in its orientation and respects the way nature works is certainly a positive. But I really want to come back to this notion that we have to make hard choices. We have to have a coherent effort. We all have interesting ideas and they're all valuable and we can say they're all going to be important. But there's a crisis and time is not on our side. And we have to make choices how we deploy our talent, how we deploy our capital, and how we deploy our policies. And I'm just really feeling that the time has come for the community to come together and take all the wonderful things that have happened and all the potential that's been created to date and find some way to come together and work together and develop a coherent plan that in some rational way puts the resources and puts the effort behind the things that are really going to be critical in preventing us from going, what Klaus said, above this 450 level and therefore causes a catastrophic climate change, which is like the pandemic. Right now, climate change is talked about like it's a flu. But the thing you're really worried about, it becomes a pandemic. And climate change, staying below 1.5, is keeping it from becoming the equivalent of a pandemic. Because once the ice caps start to melt, you're in a complete permafrost. So I'm really feeling that now is the time we should use the fact that the public has been made very sensitive to the notion that there are these, that you have to address threats before they occur. And we have to use this time to come together as a community and have these discussions that we're having here, have them in a very constructive manner, listen to all people's points of view, try to make critical assessments and come up with a coherent plan.
All right, thanks, Peter. Heidi, can you hear me from this other line?
Yeah, you sound good.
All right, great. Sorry about that. One of the challenges with technology is you're never sure it's going to work out the way that you hope it will. So a couple things here. I would say there are two main things about reducing emissions versus pulling drawdown from the atmosphere. The first is that reduction of emissions is absolutely necessary. We need to do that in every way that we can, but it's not sufficient to actually meet the problems that we're currently facing. You know, as of right now, we're above 400 parts per million, and we'd like to be at below 350 and ideally below 300 parts per million. So we have to draw down. The second piece is that reduction in emissions implies very little co-benefits along with this process. There's a way of looking at excess carbon in the atmosphere as an incredible opportunity to create something new. It's an excess amount of resource, and it's a resource that's very valuable, I think, as everyone on this panel recognizes. For biological systems, carbon dioxide is an incredibly valuable resource. The more carbon dioxide in the atmosphere, generally the better plants grow, the more carbon they can sequester, the more food they can produce, etc. So when we invite a shift in our agricultural systems, in our pastoral systems, in our land management systems, so that it is verified to be sequestering carbon and creating all sorts of other benefits, we also see healthier soil, we see a higher nutrition density, we see greater yields, we see an uptick in rural development, food security. We see women and girls, the rights of women and girls being honored to a greater degree. We see indigenous peoples being honored the way that they should be. All sorts of co-benefits that don't come along with simply reducing emissions from factories and such. And this is what I'm interested in capitalizing on.
Mm-hmm.
I think the point has been made as well, to support what Christian has said, that, you know, and Klaus said and everybody said, that reducing emissions is not going to solve the problem. And we should do that driven by the fact that we want to have renewable energy in any case, and that's the most direct way to reduce emissions. There's one little subtle point I'd like to make that I know gets lost in a lot of the discussions and in people's reaction and thinking about where we got to here today as being a result of some malicious efforts of people that put us in this bad problem. I really think we have to recognize that we're all benefited from the Industrial Revolution, and from all that carbon in the air is enabling us to have the lifestyle that we currently have. And what the issue is not that what we did in the past is bad, but now is the time we have to change. And we have to do what Christian says, we have to really recognize that we are part of nature and we can't keep on violating it the way we've been, and find a way to do things industrially and organically so they're coherent with nature. And that's why the idea that I'm trying to suggest of this mimicking nature, of having industrial technology mimic exactly what nature does, so it's in harmony with it, is important. But the final thing I want to say, this is very important. It's not exactly to reducing emissions and versus removal, but it's related to it. The only industry in the planet that has the infrastructure, has the capability to address climate change and the threat in the time scale we need, is really the petrochemical industry. And there are many signs that they're recognizing this, and there are many efforts that are going on in all our companies that, to some extent, in one way or another, having an energy industry that is thinking about how they can contribute to solving the problem. And I really want to point out it doesn't help at this time for us to fight amongst ourselves and to say they're bad guys and they're good guys and therefore be divisive, but really find a way to all come together. As they say in the pandemic, we're all in this together. Nobody's going to have a successful business if the planet goes through the disruption by climate change that is gone through, like with the pandemic. So we're really all on the same team, and we all ought to work together to do that. And as I said, our company is really having what is a very productive relationship in trying to scale up the technology with its partner in that, Exxon Mobil, and we're also recruiting others at the moment to join us in this effort, because the scale up, it's like what I say, that carbon removal or direct air capture is like the ventilator for the planet.
Yeah, on that note, I think it'd be interesting to dive into what kind of, I mean, all of you have different partnerships on the technical side as well as the business side. And I know, for instance, Regen Network has its own kind of open source team. So how does that look for you? How do you choose those partnerships, and how do they help you with the technical development of for your business?
Well, yeah, absolutely. I mean, first, I would like to address, and it keys right in with your question here, is partnerships. Who do we need to partner with? How do we scale this up around the world? In this year, 2020, there are 400 million people working on agricultural projects around the world. 400 million farmers around the world, which are each making self-interested decisions about how to manage their farms. A lot of that is based on finances. if there were financial incentives for those people to be managing their farms in different ways, which would sequester carbon into the soil, which would increase the amount of above ground biomass through the planting of trees and otherwise, we could scale this up immediately. Each of those families is making decisions each year about what to do. So as soon as they realize that they get paid through carbon credits or other initiatives that we want to bring about for the carbon sequestration, water quality, biodiversity increases that they make, we already have the infrastructure in place to do an agricultural solution to carbon. That's not to say that this should be the only solution. So I'm absolutely on board with that. We need to do a suite of different solutions. But I would argue that there isn't just one industry that's large enough to tackle this. Okay, beyond that, Heidi, for your question about how do we make partnerships, one of our beliefs at Regen Network is this needs to be backed by open science. And it needs to be backed by open source technologies so that every advance that our company made is immediately put into the commons domain. So that then any of these other companies that are on this panel or the thousands and thousands of other companies out there in the world that are working on this problem can take those advances and immediately benefit from them. The time is not now for closed source competition to try to solve this problem. The time is for cooperation and open source.
Amen. And I just want to clear, I don't disagree with Christian at all. I didn't mean to say that there's not the various people have to contribute to this. We all have to contribute. What I wanted to say was, and this would come out of a critical assessment, to get to the scale of 10 gigatons or 20 or 30 gigatons a year, that's the only point I made. That's a different level, as I think analysis will show. You can't do that just with improving your farming practices of planting trees. And I was just saying, for the additional industrial component, for that particular point, but I don't disagree at all with Christian. I didn't want to say that they're not global networks that are crucial to solving the problem. And as he said, we all have to contribute to it and be part of it together.
Thanks.
I mean, when Peter, we were talking about removing 10 gigatons of carbon dioxide every year by 2050. And I mean, we need to do that to achieve our climate targets. I mean, there should be no question about that. And if we want to reach that, then we would need to build up the biggest industry we will see in about 30 years. So that's huge. It's not just incremental growth of a company. It will need industrial innovations we have never seen before in scaling up. And for this we need to do together. We need to have the scientists. We need to have the policy workers. We need to have everyone we can have from the industry. But we also need to be aware, if we build up such a huge thing, it also needs to be accepted from the public. And there we also need to take care who is part of this network. And there, Peter, I not fully agree with you. From a technical point of view, I agree with you that the oil and gas industry, they have a lot of assets which will be important for the future. But we also need to take care, mainly at the beginning, that these solutions are accepted. So they should not be being perceived as greenwashing. They should not be perceived as a fig leaf. They should really perceived as being the solution to tackle climate change. And there we also need to have the right partners on board in terms of credibility and in terms of trust. And there we need to have strong partners who can really deliver that. And there I also see a bit of difference in the perception in US and in Europe. I think in US there you see it a bit more pragmatic than the Europeans. And I would say in US, if you see a solution which works, then you basically you evaluate it from a technical point of view. But in Europe, we have a bit of different culture, and we also need to take care of that so that we're not killing a project because of public perception and not because of technical reasons. So there, I really think we need to take care that we have the right people on board, to have the right companies on board, to do it right from the beginning.
Well, I agree with you that we have to do it the right way, but I strongly disagree with you that you don't allow for people to react to events and change and become part of the solution. And I think that attitude that there's some ideology, it's like in politics in America, you have to say, be for something, or you can't be part of the Democratic Party or the Republican Party unless you toe the line. We see the sort of lack of cooperation that engenders. And so I think that it's really not constructive to have an attitude that there are some sets of people that you don't want to partner with because somehow ideologically in doing that, even if what they're doing is very constructive, there's somehow just the very act that they're there creates a credibility problem. And more so, I would say we're in a time now where we've seen this sort of ideological debates, right? The moral hazard debate about being able to even develop a technology to draw down, have people opposing it for exactly the kind of thinking that says that there's a moral issue associated or an ideological issue associated with the use of technology. But I do agree 100%. I can't say more strongly. We at Global Thermostat are really struggling with ways that we're going to come out with a corporate structure, a corporate behavior, a corporate input that will ensure, because I'm in total agreement with Christian, ensure that the way our technology is implemented will be harmonious with nature and be harmonious with the needs of the people on this planet, specifically the poor people, the people that lack equity. The beautiful thing about carbon, about the renewable energy and materials economy, is that everybody has sun, everybody has water, and everybody has air. And so it provides a fundamental basis for an equitable technology that was deprived when it depended upon natural resources that were distributed in a way that created conflict. So I really think when you go to a new era, it requires new thinking. If you bring the baggage from the old thinking to the new era, we won't get there.
I mean, when we see how many really great projects also in the sustainability area were killed just because of public perception, then I think we cannot neglect that. I mean, there is I would say a technical point of view where I agree with you that we should look for the best solution, but we also need to take care that this is accepted, and otherwise it's not going to fly. I mean, if you I am from Switzerland, then you have a lot of components because of whatever reasons, and you cannot neglect that because these reasons or these concerns, they are real, and we need to also be sensitive for that. We're going to install a huge thing here, and I think we need to be sensitive on different levels. So I think we should not neglect that.
But Daniel, nobody would have said that people would voluntarily stay in their homes for 3 months because of a press. I think it's our responsibility as people who are technical to focus on what's going to solve the problem and help the public understand, not give into their what could be some basis of based on past behavior, some current perceptions. But to the extent that it's true that what you look at what's actually being done, you can have it do it open source, as Christian says, so everybody sees what's being done. They see how the technology is being used, to see what the efforts are doing. That should be the bottom line. Because I'm just telling you, history would say one of the reasons that we're not addressing the climate crisis right now the way we should is for the division that has people have certain beliefs that are hindering us getting there. So the solution is not to give into those beliefs, but the challenge is to get everybody to understand the true nature of the threat, what is really required to resolve it and address it.
Actually, I want to take, or Dan, you can, your last point. I actually wanted to take what we were talking about here about kind of public perception and how we actually do teach the public and teach even people in the broader clean tech community about the role of carbon removal and carbon tech. How do you approach making technology accessible and educating the public about this kind of new era of climate solutions?
I mean, what we believe is that, and I think, Peter, there we have a certain agreement. We need to make this technology approachable. So we have a lot of public tours on our plans. We're talking to a lot of people. We're also informing the community via social media, via press releases and so on about what's going on. So we would like that people understand that what I'm having here, this fuel made out of air, is not utopia, that it already exists today. And this is what we need to do. And we need to see, we need to show them that this is not dangerous. It is possible, and we can do it. So talking to people, making it approachable, and being open. And there I think we have an agreement, Peter, that we need to do that. But it might not be enough. So we also need to integrate them into the projects. We need to see how they think, so that we can react on that. So
Exactly.
I think we really need to work. We need to work on different levels to work together with the community to show them that we have no choice. We need to do that, but we need to do it in the right thing, and it's not dangerous. We just need to do it.
One of the things along those lines, I agree with you 100%, Daniel. I'm talking to you here from Northern California, where I'm setting up as part of something called the Elk Coast Institute. And the notion is to bring in people from the developing world and try to help them understand what a renewable energy and materials economy could do if implemented in their cultures and in their places. So I really agree that education, information, open source, collaboration, working together, it's put it in our university. I'm very encouraged, by the way, if I could say, I have grandchildren, and what they're learning in school really is light years ahead of what I work with at school, to say the least. But they really get it, and they really care, right? And I'll say the final thing of hope here. I teach at Columbia University, and I've noticed an enormous increase in my classes because there are lots of people that want to go into the career of what they call social entrepreneurship. That is doing something where you're innovative, you're an entrepreneur, but you're doing it for the betterment of society. And I think that's a very healthy sign. When I started teaching my course, everybody wanted to go to Wall Street and make money in the derivative markets or something like that. It's been a very profound change. And a lot of the companies, and I would even put Daniel in this, a lot of people have really gone out, and they've gone out into the world and want to make a difference, right? And you can see it. When I talk to people, there are so many young people starting firms. And as you pointed out, I think we should tell the audience, there's a lot, this is going to be one of the biggest growth areas in the 21st century. There's room for everybody. You can take your particular talents and you can do it. It's in filmmaking, it's in art, it's across the board. We're talking about a cultural shift, a fundamental shift about our relationship to nature and to each other. And it takes across the board. And I hope everybody who's listening to this and others will get in and help make it, because the interesting thing I'm saying, it's not only going to be a sacrifice to do it, but I think it's going to be a win-win situation. You're going to have a good career, you're going to be able to support your family, and at the same time, you're going to go home at night feeling you made a positive contribution to humanity. It's really a great place to work.
Yeah, that's great, Peter. I really appreciate what you just said there. And our approach at Regen Network is very much like that. We want everyone to get involved. There's a huge important role here for us to value the input of experts, but also to bring in the citizen engagement, citizen science. Every single one of us carries around in our pocket a data collector, which can be geolocated and time-stamped and collect data that can verify specific things that are happening in the world, so that when we're making choices about how we want to offset or support ecological impact around the planet, those choices can be really, really well informed. The basically approach to verification of ecological state and the quantification of that state that we use at Regen Network, we call intersubjective verification, where we correlate multiple sources of data and bind them together in something we call a data cube. Then the blockchain, which is an open and community-governed piece of infrastructure, holds that data and makes it possible for these different sources of data to be woven together to confirm or deny certain claims that various parties have about ecological state. And a basic function of a marketplace is to then bring the parties together to transact around those claims. And so as soon as that becomes open and clear and trusted, so that there's not an adversarial environment for these different actors to be working in, we've got an opportunity to really scale this up around the world.
I'd like to say something, Heidi. One of the results of this conference, I really want to talk more with Christian.
Awesome.
Awesome, great, Peter. Let's do it.
Right.
Okay, well, I think there's this is the technology panel, of course, and we do want to learn more about your technologies. I think one of the big questions that we've been seeing from the audience has been learning more about the challenges that you are facing and scaling up. We've been talking a lot about, getting to a stage where we're able to address gigaton scale emissions. How do we get there? And what are the challenges that you're having now? And what do you see is necessary to get over those challenges?
I can say something. I think, Heidi, you can say in your company, if you'd agree with this, there's this well-known phenomenon called the Valley of Death in growing a company. That really is a problem. It's a hole in the support system for entrepreneurial companies. There's a lot of people that get excited about getting in the beginning, in the ground floor of a new and exciting idea. It's relatively easy in America to raise money for new, interesting ideas. And once you get what they call bankable technology, where you've removed all the risk, the financial institutions exist. But you get into this middle ground where you've demonstrated, like all of us have, Opus 12 has, Climeworks has, we have, you've gotten a certain level of operation. And then you want to go to the next level, which is that scale up level. But you're not quite at the level and the cost and the risk reduction that suits the sort of, it's good enough to be bankable. You can't go to a bank and get a thing like you can for a construction project to build a home. And so there's a real missing thing. Now, what people have talked about is if you put something like a price on carbon or some policy, right, that will help to bridge this gap, that would be very useful. Let me just say one more word. In solar, the way that was done in the Obama administration was they had a program, sort of a loan program. It got notoriety for a while, where the federal government would come in and help reduce the risk to the financial backers by sort of backing it up. So for those first pioneer commercial plants, they provided the capital, or they provided the insurance against the risk, right? The government did. So something like that is needed in the carbon space, and you can see it's beginning to happen. There is 45Q that was passed by Congress that starts to give, $50 a ton benefits. California is passing legislation. It's beginning to happen. But again, there's not a global systemic approach to this to fill that hole. But that's what I would say at the moment is the biggest gap.
Okay, so yeah, and digging into, I think a lot of folks are wondering about kind of the scientific, if there are scientific barriers that are not just about the scale up and the ecosystem itself. Can you talk a little bit about that? Is it like the technology and the science is totally set and then we're ready to go? We just need some funding to do it, or yeah, what does that look like?
I would say yes to that question. We're ready to go. All we need is money.
I would answer, Christian, just
go ahead, Daniel. Yeah, no, go ahead, please.
Okay. I mean, we also need to be aware with this technology. We are still at the beginning. This technology works, but it's not. I wouldn't say it's ready for gigaton removal yet. So with Climeworks, we believe that in the first step we need to further improve the technology. In the next step, we need to make the plants bigger, and in the third step we need to scale up manufacturing. Just be aware of the challenge we have in front of us. We said that by 2050 we need to remove 10 gigatons. This would, in average, need a global growth of the industry by 60%. We have never seen in the past an industry growing by 60% every year over 30 years. So what we have in front of us in terms of scalability is huge. And this I would not underestimate. We need to build up the logistics. We need to build up the supply chains. We need to hire skilled people. We need to build up the organization. Money, of course, is out there, but you also need to structure all the financial issues. And I think this is not, we cannot underestimate. And this is a huge challenge we have in front of us. And there again, we come back to networks. We need to collaborate with others which have the experience in running such big companies and these infrastructures. And that's what I believe is needed. And I fully agree with Peter. We need to have legislation in place, otherwise it's not going to work.
So, there is some distinction here. I mean, we believe, and we are already believe we're in the stage where we're starting that. That's our joint development effort with with Exxon is to scale up, because we believe we've gotten to the point where we think we have a technology that can scale up. We'll have to show that, of course. And of course, that's not guaranteed, but it looks promising, and that's why we have the effort. But I would agree, and again, this is why I come back to my comment. There are large, I can take various companies, General Electric, Siemens, you take all the industrial giants at the moment. They're all deeply embedded in producing machinery for the petrochemical industry, right? That's a big part of their business. So as the switch from fossil fuels to renewables occurs, and the switching from petrochemical normal processing to taking CO2 from the air and hydrogen from water starts to grow, those companies will face a choice. Their markets are in decline, just like coal has been in decline, right? And they'll either switch and try to convert their infrastructure, their existing infrastructure, to be able to provide the scale and logistics that Danny was talking about, or new companies will come up to replace them, right? And so I hope, because I can, exactly what Daniel said, if the current ones don't switch and become part of helping meet this exciting opportunity, then it's going to take a long time to build up a new infrastructure. Our hope is that as the path becomes clearer, that the existing infrastructure will say, yes, right? Let's join in and let's be part of solving problems. Just like, what is it? I think Exxon made rubber for the war in World War II. General Ford made tanks, switched its automobile manufacturing to tanks in World War II. I see no reason why, facing this threat, that we can't hope that the existing industrial infrastructure will retool itself and go where the new opportunities are and make new infrastructure, adapt the existing infrastructure to the challenge we face.
Hey, everybody.
Hi,
this
Heidi.
is Matthew Eshed, host of the room. I want to really push the three panelists to give us a run through of the technology behind your product and your service. It could be as, don't share what you don't want to share, but the attendees are really hoping to hear more about the specifics, the chemistry, the thermodynamics, get into the technical details. I think that the people in this room are a lot of engineers and scientists, and that's really what they're looking for. So for the next few minutes, it would be great to hear y'all address that. Thank you.
Cool. First, I just want to answer really quickly, less than a minute, Heidi's question. Is this technology ready to deploy? The technology that's at the basis of what Regen Network is doing has been ready for the last 100 million years. For example, the rotational grazing of animals, there were 30 to 60 million buffalo in North America before the year 1500. And in that time, they built a huge amount of topsoil in the middle of the United States. The soil in Iowa is famous around the country. It's literally meters and meters and meters deep. So as the Savory Institute says, it's not the cow, it's the how. Right? We need to upgrade our management techniques. As soon as we start intensive management of grazing animals, there's literally billions of acres that are ready to turn this on around the planet.
Our technology, just quickly, is based on using the same device that's in the catalytic converter of your car to remove the CO2 from the atmosphere instead of the NOx from your automobile. It's called a monolith contactor. It's many parallel channels, a couple millimeters in opening, and 1/10 of a millimeter walls through which the air passes through. And as Klaus said in his introduction, the key issue is the first step of absorption. You got to get that low. The minute you get that to be low cost, you're in great shape. Well, it turns out that the monolith contactor in your car is an unbelievable device. It lets the air go through tangent parallel to the wall with very little resistance in a unique state of matter flowing called laminar flow. That laminar flow enables us to have the CO2 go through our devices about 3 to 4 times faster than any other technology in doing direct air capture. And that 3 or 4 times faster means that our capital can capture 3 or 4 times more CO2 per unit time than doing another different type of contactor, where the resistance depends upon the velocity squared and not linear like it does in laminar flow. Your catalytic contactor is also unbelievable in the sense of how much surface area it has per volume. And namely, our device is 6 inches deep, and Carbon Engineering's device is 10 meters long. We have as much surface area in our device that's 6 inches deep compared to their contactor that's 10 meters long. So it's in this first step of coming with a contactor that has very low resistance to flow, so you can high speed through, very efficient contacting, very fast contacting, that we believe has enabled a cost breakthrough that is, as I said, put us starting at around $200 a ton within really clear shot of getting to under $50 a ton in a very near time frame.
Since you're also doing direct air capture, may I point out a bit the difference to technology Global Thermostat is using. So the core of our machine is a metal box of the size from 2 times 2 times 2 meter, which we're calling CO2 collector. And inside this collector, we do have a filter material. It's an amine-based filter material, a solid filter material, not a liquid one, which is capturing the CO2. And the basic chemistry behind is CO2 you can assume as an acid. We are forming a base, and they are forming a weak chemical bonding when they get in touch with each other. This happens at ambient temperature. And as soon as this filter material is saturated, we're closing this collector, and then we're heating it up. And by heating up, you're basically releasing the CO2 again from the filter material, and then you can capture it. So the chemistry behind is not new. I mean, this is used for decades. I think what is new is that we have developed a filter structure we can handle such low concentrations as we have in the air. And the CO2 which is released is quite pure. It's close to 100%. So you can, for example, directly use it to produce fuels. You can directly inject it into greenhouses or underground. So the method behind this is I would say is rather simple. And as also Peter was mentioning, it is important that you get an efficient filter structure, so that you have a high dynamic in the capturing process, so that you can keep basically your capital cost low. And this is the secret behind an efficient direct air capture plant.
Great, thanks. Our technology is quite a bit different than the others here. If I was to correlate, I would say we're starting with photosynthesis as our carbon capture technology. But what Regen Network is really working on is we're building a biological carbon marketplace and registry where we can bring together the producers of ecological impact, biodiversity, carbon sequestration, water quality, et cetera, and the purchasers of that impact, whether that's government programs or corporations wanting to do carbon offsetting, et cetera. And Regen Network sits at the middle of that. Our suite of technologies, our whole software development kit is meant for the collection and organization of data, the verification of ecological impact on the ground. We're using a lot of remote sensing, satellite, automated algorithmic sensing capabilities from space to be able to verify whether carbon has been sequestered into the soil, whether above ground biomass has been accumulating, whether biodiversity has been happening, et cetera. And then issuing cryptographic tokens onto a public permission blockchain that is all the data is shared with everyone publicly, so that those can then be purchased and traded in a way that's very robust and removes the ability for those credits to be double counted by anyone. This is what we think is necessary for real accounting to happen in a way that needs to, so that when someone says that they're offsetting their negative impact, we can be assured that they really are offsetting the negative impact and not accounting for it in a way that's kind of, sleight of hand for the rest of us.
I must say, I really like the Christian's approach. I think that really is a needed thing, this accounting verification, because there's a lot of greenwashing going on that really needs to be addressed, because it's wasted effort in a critical time. I would just say one thing and I've made this point before, per square meter on the ground, our trees, as Klaus calls them, for taking CO2 out of the air, is 100,000 times more effective than a tree. That is, we take out per unit time, per unit square meter on the ground, 100,000 times what a tree does. That 100,000 difference in footprint is the reason that trees can take you so far, right, to remove the CO2, and soil can take you so far, because it is, as Christian said, driven by the photosynthetic process. The photosynthetic process is a 2% efficient process. Human beings can take the sun per square meter on the ground and take it out 10 to 20 times more effective. So all I'm suggesting is we have to live in harmony with nature. I'm here in beautiful California. Nothing is more important than living in harmony and having our efforts, our farming, our grazing, everything that Christian said, has to be reformed, rechanged, so we don't continue killing the system that we depend upon. But at the same time, in addition to that effort, there is this need, because of the emergency, to have a technocratic approach that can raise the level raise the level of carbon removal in the time scale necessary and do it efficiently. And getting back to my discussion with Daniel, I'm very conscious, we're very conscious, that has to be done in a way like the natural system. They were very concerned that the impact, the externalities that have been ignored to now, both whether they be the natural externalities or the human externalities, that those are heavily considered in how the technology is used. Mm-hmm. And then we can all be in harmony. What Christian is doing and what I'm doing are both natural. He's as natural as a tree, and I'm as natural as a tree. We're just weird trees. And so we just have to act in a natural way, in a conscious way, and not regard ourselves as somehow being unnatural because we have behaved unnaturally. That's true. But we can start behaving more naturally together.
Great. All right. With that, it looks like we're hitting noon. Thank you for the discussion and everyone for being part of this.
Thanks everybody who attended these sessions. Thanks for your passion and your desire to change this world in a positive way. But I will say both on a micro level,
Oh no, Christian, I lost you.
Oh. Okay.
The cliffhanger.
Ciao, I'll see you back in meeting room A.
I'll send him a message. See you guys, thank you.